Okay, let's jump right in. The sheer demand for computing power we're seeing, especially
Mhm.
with AI just exploding everywhere, it's putting, well, enormous pressure on our digital infrastructure.
Huge pressure. We need data centers that can scale incredibly fast,
Yeah.
but they also use just vast amounts of energy.
And that brings the whole environmental impact into sharp focus, doesn't it?
Absolutely. And the old way, building these gigantic, often remote data centers, it's starting to show its limits.
How so?
Well, for one, they take ages to build, years sometimes. The energy costs are becoming a massive line item.
Mm.
Plus, there's more and more focus on carbon footprints, and crucially, where data actually is data sovereignty concerns.
Which is a perfect lead-in to what we're diving into today, Edge Nebula. They seem to be offering a pretty different take on data center solutions.
Yeah, a really novel approach. We've been looking through their website materials for this deep dive.
Right. And our mission really is to get under the hood. How does Edge Nebula plan to tackle these big issues? Scalability, speed, sustainability, and this data location piece, especially for AI and the cloud.
Exactly. We want to figure out what makes their offering tick.
So let's just establish the baseline. This need for digital infrastructure, it's not exactly slowing down, is it?
No way, it's accelerating. If anything, AI advancements, cloud services becoming the default, machine learning everywhere, it all demands more compute
And generates more data.
constantly. The volume is just rocketing up.
But the traditional fix these huge, isolated data facilities, you said they're hitting roadblocks. What kind of less obvious problems pop up there?
Well, beyond the power and the green issues, think about flexibility or the lack of it.
Ah,
These are massive investments, right? Long construction times.
right.
If demand suddenly shifts or a new chip technology comes out,
Yeah.
adapting those giant centers, it's slow, it's expensive.
Okay, that makes sense. Inertia.
Yeah, exactly. And then there's the simple physics of getting data from those remote sites to, say, dense cities where most people are. Latency can become a real issue.
Right. And Edge Nebula seems to be looking right in the cities at resources we're not even using properly. They mentioned loads of empty office space in the UK.
That's definitely a big part of their pitch. Repurposing existing buildings like those vacant offices makes a lot of sense with work from home trends.
And they also talk about using something called stranded power.
Stranded power, yeah. That caught my eye too.
Okay, we need to unpack that. What is stranded power? Why is it useful for a data center?
So basically, stranded power is electricity that's generated, but, well, it can't easily get onto the main grid or isn't needed locally right then.
Why would that happen?
Could be lots of reasons. Maybe
Huh.
not enough transmission lines, maybe a local factory closed down, but the power plant is still there,
Yeah.
or just fluctuations in supply and demand. Edge Nebula's idea, it seems, is to find these pockets of unused power and essentially plug their data centers directly into them. So energy that might otherwise be wasted gets used efficiently.
That's clever. Turning a problem into a resource? Okay, this is getting interesting. So what's their core solution then? Speed and scaling seem really high on their list.
Oh, definitely. They talk about infinite scalability. Big claim. And deploying data centers in weeks.
Weeks, not months or years. How on earth do they plan to do that?
It sounds like it all comes down to their modular design.
Modular, like building blocks.
Pretty much. Standardized, self-contained units. They build them, ship them, connect them together quickly. It bypasses a lot of the traditional construction bottlenecks.
Ah, okay. So it's not just faster to set up initially.
Right. It probably makes upgrades and maintenance easier too. Swap out a module instead of renovating a whole building. Less disruption.
That agility. I can see how that would be a huge plus for, say, an AI company that suddenly needs way more power.
Exactly. That kind of responsiveness is just hard to get with the old monolithic model. But let's talk about the sustainability angle. They seem to really emphasize that too.
Yeah, the eco-friendly data centers. Repurposing those empty city buildings we talked about.
And think about the combined benefits there.
Yeah.
You're avoiding the carbon cost of building something totally new from scratch. The concrete, the steel, the land use.
Good point. Embodied carbon.
Right. And you're potentially bringing activity back to underused parts of a city. It's not just about the data center itself.
They also mentioned using that stranded power efficiently and maybe even reusing the heat the computers generate.
Yeah, heat reuse is a smart move.
Hmm.
If you can channel that waste heat into, say, a local district heating network or something similar, your overall energy efficiency shoots way up.
And cooling. AI systems run hot.
They mentioned highly efficient liquid cooling, which makes sense. For the kind of power density you need for AI chips, liquid cooling, maybe even direct-to-chip, is way more effective than just blasting air around. Less energy spent on cooling overall.
Okay, so fast, scalable, and greener. What about where they actually put these things? They seem very deliberate about being in or near cities.
Yes, that's clearly strategic. They say it's customer-driven, putting the infrastructure close to where the demand actually is,
Yeah.
in and around urban centers.
So bucking the trend of going out to the middle of nowhere for cheap land? Why? What's the payoff for being close?
Latency, primarily,
Yeah.
especially for AI.
Right, the speed of light delay.
Exactly. If you're doing real-time AI processing, like for autonomous systems or maybe complex financial modeling, shaving milliseconds off the data travel time matters a lot.
And being local helps with that data sovereignty thing you mentioned earlier.
Definitely. Data sovereignty, keeping data within specific borders subject to local laws, is becoming a massive issue for businesses and governments.
So it's about control and compliance.
Precisely. If your data center is physically in the UK, for example, you know UK data laws apply. You're not shipping data across borders unintentionally. It gives companies much clearer control and helps meet those regulatory requirements.
Makes sense. And they specifically call their infrastructure AI-ready. What does that mean in practice? Is it just the power and cooling?
That's a big part of it, yes.
Yeah.
Handling the intense power draw and heat from GPUs and other AI accelerators. But it probably also implies the right kind of high bandwidth, low latency networking within the data center and connecting out.
Uh-huh.
Everything optimized for those demanding AI training and inference jobs.
And presumably, this whole approach, reusing buildings, using stranded power, efficient design should make it cheaper too.
That's certainly the implication. Lower capital expenditure compared to buildings from the ground up, potentially cheaper power.
Mm.
They seem to be positioning themselves as a more cost-effective option than the giant hyperscalers, at least for certain needs.
They also touched on interconnection services. How important is that piece?
Oh, very important. It's not enough just to have the compute power. You need fast, reliable ways to get data in and out.
Like network connections.
Exactly. High-speed links to major internet backbones, maybe direct connections to cloud providers, robust connections between their own distributed sites. This ensures data moves quickly and securely. They mentioned mesh network resiliency too, which means building in redundancy. So if one connection fails, data can take another path.
Got it. Okay, we have a good picture of the what. Let's talk more about the how. What really makes their approach different?
I think that modular design is really the linchpin. It enables the speed, the scalability, that Lego block approach, essentially.
Build as you grow.
Right. Add capacity incrementally, where it's needed, when it's needed. Very different from guessing demand years in advance for a massive build.
And this retrofitting of existing buildings, I mean, surely it's not just a case of rolling in some server racks.
Well, definitely not. It's a complex engineering job. You need to upgrade the power infrastructure significantly, install sophisticated cooling systems, likely liquid, as we said, ensure top-notch physical security, fire suppression, network connectivity.
So it's specialized work.
Highly specialized. But the potential benefit is faster deployment and lower environmental impact compared to starting with an empty plot of land.
And the stranded power, how do they actually grab that? Is it just finding an unused socket somewhere?
Huh, probably a bit more involved than that. While the specifics are likely proprietary, the principle would be identifying those underutilized power sources, negotiating access with the utility or generator, and then deploying their own power management tech within their modules to draw and condition that power reliably.
Needs close ties with the energy companies then.
Almost certainly. Partnerships would be key.
They list enterprises, service providers, platform providers as potential clients. Who do you think benefits most from this model?
Well, anyone who really values that speed and flexibility, AI startups needing to scale quickly, cloud providers wanting a footprint in a specific city without a massive upfront build, enterprises with strict data residency rules or latency-sensitive apps, edge computing applications.
So quite a broad range, potentially.
I think so, yeah. If those factors, speed, sustainability, location, sovereignty, are high on your list, their offering seems tailored for that.
Taking a step back then, looking at the whole data center industry, could Edge Nebula really shake things up? Are they a potential disruptor?
I think they have the potential, yes. They're challenging that established model of centralization, bringing high-performance computing closer to the edge, closer to users, and wrapping it in a sustainability narrative. It's a compelling combination.
It's almost like distributing the cloud, weaving it into the city itself instead of keeping it far away.
That's a good way to put it, bringing compute to the edge of cities. Their whole vision seems to tie together scalability, being green, security, and crucially, making it economically viable. They're tackling a lot of the big pain points we're seeing with AI and cloud growth.
Okay, let's try and boil this down. If we were to summarize the key takeaways from our deep dive on Edge Nebula for everyone listening.
I'd say the main thing is this. Edge Nebula is putting forward a genuinely different model for data centers. It promises to be faster to deploy, easier to scale, more sustainable by using existing spaces and power sources, and more secure in terms of data location.
And particularly relevant for AI and cloud users who need that low latency and data control.
Exactly. It's built around repurposing urban spaces, using that stranded power concept, and employing that flexible modular design. It's definitely an alternative worth watching compared to the traditional hyperscale approach.
So, a final thought for you, the listener, to chew on. If this model of repurposing city infrastructure works for data centers, what else could it work for? Could we apply this thinking using existing assets more smartly to other big resource challenges? What might that mean for how our cities develop, how we approach sustainability more broadly? Definitely something to think about.
It really is. It encourages a more creative look at the resources we already have. So
Yeah.
if your work touches on AI infrastructure, cloud strategy, or just sustainable tech in general, Edge Nebula's approach is certainly something to explore further. See if it fits your own specific needs and priorities.